Well, the table saw, as you guys all know, the better tuned it is, the nicer it's going to be to work with, and to be able to produce that quality of work. Needs a saw that is fine-tuned and will do what you want it to do. There's a number of things that you need to do to get this all totally set up and working. We don't have enough time to do that this morning. What I thought I'd concentrate on was different methods or techniques for checking the alignment of your miter gauge slot with your saw blade. So to do that, we'll take the insert out. That's another variable, and as you're working through different systems or methods of checking the alignment of that saw blade, you want to eliminate as many variables as you can, and you want to be as consistent as possible. And I'll pass a handout around, but there's a number of standard things that you want to do with your saw, no matter which method you use. Certainly, first and foremost, is unplug the thing, or shut off your power source to it. Remove the insert. You don't want to use an old blade that's been around, so you want to take that off. Now it's important that when you put your good blade on, that the supports that go on either side of your blade, those need to be clean, free of dirt, grime, rust, any kind of particles. They need to be nice and clean and flat. So I'd suggest using a brand new blade, best quality blade that you can afford. So you want to snug that up just like you would mount the blade to use. And so we want to be sure to set your blade at 90 degrees. I'll run the blade up as high as it will go. And there's a couple different ways of checking your blade. One is to just use a good mechanic square. When you do that, you want to set that and make sure that it's in between a tooth. The other thing that I like to use, particularly with my old age and eyesight, is one of these little tilt boxes or Wixies or whatever it's called. So we need to zero this in. Okay, so we set that again, stay below 2. And the challenge is, and since I took the motor off, just to make it easier to transport, that looks nice. Okay, so we're good there. Let's see, make sure. Okay. Whatever device you use for measuring, you want to be sure that you're measuring perpendicular from the miter gauge slot to the blade. The one method is to make or buy a runner that fits in your miter gauge slot. This one fits pretty decent, so I didn't have to do anything with it. When I saw at home, I got a Rockler miter gauge runner that had a bunch of little set screws along the length of it, and you use a screwdriver or Allen wrench to adjust those set screws so you get a nice snug fit. You want this to fit snugly but still slide smoothly. And I discovered with those other guides, I had that guide or runner all set. I attached a piece of plywood to it, and I used 3 screws. One screw, the hole's off just a little bit, and when I fastened that on and put it in the saw, I could tell that that had distorted it a little bit. So I took one of those screws out and made all the difference in the world. So just a little aside. Now, what I'm going to demonstrate first is using a dial indicator. These are nifty little devices. I don't know whether can you get a pretty decent close up of that? Okay. Just a quick tutorial on the dial indicator is that the stem will have a travel of just a little over an inch. And on the gauge, and as I push the stem in towards the dial, that's going to increase in measurement or the numbers. The little dial there, that keeps track of the number of hundredths of an inch. Here are numbers around the outside, the ones in black, those are recording hundredths. This records tenths of an inch. The black numbers are hundredths of an inch, and then every gradation in between 2 black numbers is thousandths of an inch. The red numbers on the scale, if you can see it, they're actually going in a different direction as far as the value. And so the black numbers, as the stem advances, you can use that to record a positive, and as that stem goes away from the dial, that's going to be that can be measured or recorded by the red numbers and considered a negative movement, if you will. The outside ring is called a diesel, and it can rotate around so that you can set the 0 mark wherever you want. That simplifies using the dial indicator and keeping track of what you're doing. So I've got a little sled here with this attached to it, as you can see. Just make it snug, you don't have to get orangutan strength on it. So if I use a blade, and you can't see it from there, but I've identified, there's a couple different ways that you can register your dial indicator. One method would be just someplace on the blade itself. Some people will do that. Some people recommend actually bringing your dial indicator right to the edge of a particular tube. On the saw blade, I've discovered where these kind of cutouts are in a different blade. That affects the thickness of the blade. And if you run your blade all the way around and check and watch your dial indicator, you'll see that these areas of these cutouts, that it does affect the blade a little bit. So I choose to use a tooth. I'll mark that. What I like to do is I can simplify finding that tooth and keeping track of it. Is just put a little bit of tape on either side of that tooth. So for us old folks, a device like this is really handy. If you want to, and you should get really particular about where you set the end of that dial indicator. And I mentioned on there that you want to try to work in kind of the mid-range of your dial indicator. You don't want to work at the extremes of either end if you can avoid it. The other thing, by keeping your dial indicator perpendicular to the blade and perpendicular in a vertical plane, that's going to be important. You don't want that indicator going at an angle because it might slip on that surface. The stem might bind just a little bit and give you a false reading. So I sit. I've got that set at 0. And at the top of the dial indicator, you can take a hold of the top of it, and when you build your setup, you got to be sure that there's room for the top of that dial indicator to move. It's got to move back and forth Then I'll take and just rotate my saw blade. Register that tip on the exact same spot on that tooth where it was before. Is there any way that you can see the top of that dial? Not very well. Brings up another point that when you read your dial indicator, you need to be looking right directly straight on the face of it. You don't want to be looking at an angle, because that's going to give you a little bit of a false reading. So this shows that we are at a negative about a little over 13 thousandths. So our needle has actually gone out further. The tip of our dial indicator has moved out further away from our dial indicator. So that's telling me that the blade is angled a little bit to my right. It's 13 thousandths off of being true parallel with my miter gauge slot. Now, if I take and push on the side of my miter, or my base here, it moves about a thousandth of an inch. But if I push down on this side of it, see, I can move about a couple, 5-6 thousandths of an inch that way. So the important thing is that you do multiple measurements, and as you go from, as you do your multiple measurements, as you be as consistent as you can, with blades. It's nice to have a motor attached to it so it's not running free like that. So it's important that you do everything as consistently as you can. So if you set this up with the thing just sitting there, then very lightly, gradually, just move it to the other end. You don't push on it, you don't push down on it, or whatever, okay? So do multiple measurements, because there will be a little bit of variation, and then you make your adjustment to your saw table from there. The dial indicator, you can get one of those for about $20. You can also, for about another 20 bucks, you can get a magnetic base. And you can fasten this thing on and fasten your dial indicator to this and get all kinds of different configurations, or whether you're checking your saw blade or drill press or whatever else you want to check. And see, I've added just a piece of sheet metal, worked very nicely for a magnetic base. The other thing you could do would be to just take your miter gauge, fasten a piece of wood your miter gauge, and then attach your dial indicator to that. The closer you can get your dial indicator to the top of your table, that's going to give you a longer distance of measuring the deflection from one end of the blade to the other. With the setup that I've got here with a 10-inch blade, I have about 6 inches travel from the front of the saw to the back of the saw, working on the same spot of that blade.
Bill?
Yes?
I have a question about, for the group, about what we think happens when you rotate that blade. Because
Okay.
one of the
Dave's comment question going out to you guys as a group is, what happens to that blade from a static position to when you're actually running?
no, well, not,
Am I wrong?
in the measurement process,
Okay,
what I do, and I'm probably doing it wrong, is I clamp the blade, I put a clamp on the blade down here and a clamp on the blade on this side so the blade can't move. And then I just move the dial indicator from one side of the blade to the other. And I don't know, I think there could be a difference depending on the blade.
The teeth, I'm sure.
there is,
The teeth could be a little different.
or at least I've seen minor differences on the blade, and by using your dial indicator and staying on the same part of the blade from one end to the other, you eliminate any unusual or oddball deflection that would be in the blade itself. That's one variable that you eliminated.
Well, you mentioned the thinner spots where the cooling slots are, and if you move to a different spot of the blade, you might be in a thinner or thicker part of the blade.
What was the question?
The difference between moving the tooth over and measuring off the same tooth, or measuring from different teeth, right?
So you're just restating his question?
That's what he was asking
Yeah.
about.
I've never seen a flat saw blade.
Yeah.
Never have. The way I do it is very similar to what Bill does.
Yeah.
I put a magic marker dot on my saw blade and I'll rotate the blade around because it's going to be the same from the center line of that spindle all the way around. And that same dot is going to be at the same angle here as it is here on that spindle. So the way Bill's doing it is fine. Good. But I would not clamp the blade because you're just adding deflection to the blade then.
The other thing you can do would be to purchase a disc like this. One use for it, a disc like this, if you don't want to use it for calibrating your saw table, would be to use it as a backing for sanding disc. Chuck that in your saw, and now you've got a 10-inch sanding disc. A bolt action pen, I traded to a machinist who went around the outside of the rim here and gave me a nice uniform registration around the rim of this disc. But I wanted to show you the saw blade because that's plenty good enough. The other thing I discovered was just using a plain piece of oak, drill a hole in it that fits over the arbor, and draw a center line down through the center of it, and I had to take these off because it wouldn't fit otherwise. Otherwise I would use them. Just a piece of 3/4 inch oak, about 2 inches wide, 3/4 inch thick, and about 10 inches long.
Bill, did you do that on your saw stop too?
Pardon?
Did you measure your saw stop when you got that?
Yeah, I found that I used this on my saw at home, and it was off, what was it? I forget now, 7 or 11 thousandths of an inch. Kind of surprised. I thought it'd be a little bit closer than that.
And you have to move the whole motor to adjust that? Get that trunk?
On the saw stop, it's got, at the front of the saw, there's a pivot pin. I've got to loosen 4 bolts, and then there's 2 set screws on the back of the saw on either side. And so you figure out which way you need to change the direction of your, in that case, of the tabletop. And so you loosen one side and tighten the other side to adjust the. So when I tighten the nut down on this piece of wood, I'll snug it up just like I would when mounting a saw blade. Again, you don't need to make an orangutan tight. Now, before I change things, you want to go ahead and set up your blade, use your dial indicator on the side of the table saw that you use most commonly. Now for the purpose of our camera, that's not going to work, sorry. So I have to stay on this side. Okay. Now, the advantage of the piece of wood is that it gives me a longer distance of travel from the front of the saw clear to the back of the saw. And basically what that does is that just kind of amplifies the measurement. And when you get to the point where you're adjusting your either the tabletop or your trunnion attachment, depending on the type of saw you have, to have that extra length, it makes it a little bit easier to fine-tune that distance and that measurement as you're bringing that blade and tabletop into alignment. Couple precautions. Again, you're going to want to not let your piece of wood rest on the tabletop. You don't want it to catch on there, and so you just very lightly, gently lift it up a little bit wherever that dial indicator hits on your center line that you've drawn. Make a mark there, and then go ahead and rotate to the back of the saw. Now, in this case, I could go a little bit further, so I don't want to do that. I want to have uniform travel from the center of the saw, from the front of the saw to the center of the saw to the back of the saw. I want that distance to be the same front to back, okay? And what I found was that a piece of wood was so much easier and faster to use than trying to home in on edge of the tooth, because the tooth is, you know, different thicknesses, and you want to pick, if you use a tooth, you want to pick a tooth that's angled out towards the side of the saw that you're working on. And I found a piece of wood, this was faster, it was easier, it was just as reliable, or maybe more reliable than working off the saw blade.
What about moisture or warpage in the wood?
That's not going to be a problem,
Consistency.
because you're
and everything.
making your measurement at a set period of time. Now, if you want to save that piece of wood, record your measurements, and then maybe 6 months later, say, oh, you know, I ought to check my saw and see where I'm at. And you want to compare it with what you did 6 months earlier, then that could make a big difference.
There again, if you use the wood, and if it's 5 years later, and the wood has warped and it's twisted and it's cut, it's not really going to make any difference, because you're choosing to test it in that moment in time.
Right.
And it will still be relative at the front of the saw and the back of the saw, whatever it is, it's going to be consistent. Myself, I wouldn't have used oak. I'd have used something much finer with maple or something like that, because the divots in the oak, you can get a different, slight reading in the point of the indicator. But other than that, yeah, spot on.
That was an unpaid political announcement. And you're absolutely right, that you will notice, or you might notice, between the annual rings, particularly in like you said, the oak, there will be some significant changes there. And again, you don't feel it, but when you are measuring thousandths of an inch and you're trying to get this thing right on, it can make a difference. So, good point.
There you go.
Yeah.
They make setup bars out of aluminum T&J plate, which is a precision aluminum plate, that do exactly what your bar do there. It doesn't matter. Actually, the shape doesn't even matter, as long as you always go to the same spot, and as long as it's rigid relative to the shaft. And those setup plates are really nice. They aren't terribly expensive, and that T&J plate is flat enough. You actually minimize. You can have some air in terms of going back to the same spot, and still screw your measurements up. And it does exactly that with a nice smooth surface that isn't going to get any defense. The other thing you do is buy a wider contact point for your indicator.
Yeah.
Use like a 1/4" wide button, and then the grain doesn't matter at all.
Yeah.
Unfortunately, those typically only come in sets. And a Sharpie's your friend. Make a nice little circle and always hit the same spot and like it good.
Yeah. I mentioned in the handout that, you know, this could be a piece of plexiglass or metal or whatever. Again, like what I was saying, something that's rigid enough that the pressure from your dial indicator is not going to cause any deflection in it and give you a false error. For demonstration, the compo is all covered in rust. So I think it's fixable now. Depending on how the saw is built will determine what you have to do to get that blade and miter gauge in alignment. And that's maybe another demonstration, but you're just going to have to go back to your owner's manual and figure out what works best or what they recommend. This is an old Craftsman, back I think when they made quality Craftsman table saws. But a contractor saw, basically, your trunnion and everything is mounted to the top of the saw, and so you got to loosen those. Cabinet saws, everything is mounted to the cabinet, and all you do is move the tabletop. All right, a couple other methods. I'm not sure. Let's see. Let's stick up order here. Okay. So you can use a digital measuring device. You have some sort of something solid that you can have on your saw, and let's see. Let's go ahead and take this off here. So for the sake of camera, so you can take your digital measuring device and register against, say, this corner or whatever, and bring the other side over and register it against a particular tooth that you've selected, and then come back to the other end of the saw, do the same thing, and go from there. And that should work quite well. The nice thing about using this is that, again, you're able to come down closer to your tabletop. That's going to give you a greater distance of travel and make it a little bit easier to make any adjustments. Another method is over in Africa someplace and you don't have much in the way of tools, you can use just a combination square and feeler gauges. Guess I could look a little nicer for the camera, but I don't know.
You got a t-shirt now.
So I think most of you are well aware, feeler gauge has strips of metal, all different thicknesses. This would be a rather tedious method, but it certainly could work reasonably well. So you start out registering the side of your combination square against your miter gauge slot, and again, having picked a particular tooth, you move that over until...
Bill, you could do that one on the other side,
Yeah.
since you're not limited by the length there.
So bring that over until it just touches that tooth. And I'm not going to spend a lot of time digging with it. But then you take that same tooth, move down to the other end of your saw, and determine, okay, is there a gap there, or is it closer and you're not able to get your combination square registered in that slot? So wherever you find the gap, you want to work on the other end of the saw. Set your combination square to what's going to be the shortest distance between the edge of that miter gauge slot and that tooth. And then come back to the other end, use your feeler gauges, and determine what the width of that gap is, and then you know which way you need to move your blade, and then you're going to have to, excuse me, take that distance and start working with different thicknesses of your feeler gauge and work around. So it's a workable arrangement, but it's going to be quite tedious to get that accomplished.
Yeah, Bill,
Yes, sir.
on that, is there any reason to know what that number is? Because it doesn't relate to anything when you start adjusting, does it? Just to check it, once you get it down where you think it's pretty good, you may want to know whether it's 2,000ths or 3,000ths, but really
Yeah,
knowing that number doesn't help you much.
That's the bottom line.
Yeah,
It all depends on how fussy you want to be in the alignment of your blade. The guys at Purdue, at their wood shop, they go through and they check that saw once a week. And they want that saw totally right, dead on. Now, depending on who does that, there's one individual that likes to use a dial indicator. There's another individual that uses a different method. They still come up with the same results and everybody's happy. Okay.
That's assuming they use the same side of the miter slot?
Yes, yeah. Now technically, those miter gauge slots should be the same, but you might want to set up a way that have a runner on both sides and check front and back and just kind of see, just really how true are your miter gauge slots to each other.
what do you do if they're not true?
All right. So, like I said in the handout, there's a bunch of other things that could be done. One would be, again, checking your miter gauge relative to a saw blade. The one thing I would say, if once you get your blade where you want it and you're running out of time, because this process will take time, and you might as well set aside an afternoon or an evening if you've never done this before with your saw, because you don't want to be in a hurry. You want to be able to take your time, think about what you're doing, and come up with a result that you're satisfied. But the other thing I would recommend, if you do nothing else from that point on, the one other thing that you should do, and that's check your fence to make sure that it's at least parallel to your blade or your miter gauge slot, which should be roughly the same. And again, the guys at Purdue at the wood shop, they will set up their fence so it's dead on parallel to that blade. Other people will say, well, I'm going to have the end of my fence just a couple thousandths away from the blade, but you want to be sure that that fence is not crowding that blade. that it's angled towards that blade, because you're going to burn your wood when you're doing rip cuts, or even worse, you're setting yourself up for maybe a kickback from that piece of wood as you're going through, and then you're going from a wider gap to a narrower gap. So I would say definitely check your fence. And then from there, at another time, you know, leveling your throw plate, leveling your wing, you know, making sure they're where you want them at the right height and all that. So there's a lot of other things that need to be done. Now, I put a little note at the end of your handout, and that machinist friend of mine, when he bought his table saw, before he even used it, he took it all apart and replaced critical bolts that came with a saw with grade 5 bolts. He said the grade 5 bolts, it's harder steel, they're less likely to stretch, the threads are better made, it's just a better quality bolt, and when you tighten those, they stay where you tighten them, and that piece will stay where you want it to. He said you could go to grade 8, but he felt like that was overkill. You didn't need to spend that extra money. So I don't claim to be an expert. I just shared with you this morning what little I know. Yes, sir.
I would urge anyone who has a table saw, radial arm saw, miter saw, anything like that, get an indicator, borrow an indicator, borrow a friend that's got an indicator, and just, if nothing else, just rotate that blade around, see what that blade does. You'll be surprised how round it is, or how much wobble there is to that blade. And what Bill was doing here today will go a long way to improve your cut quality. Thank you.
Okay. Thank you, ladies and gentlemen.